Welcome to BVR Physics and Chemistry Made Easy. Today our topic is about classification of elements. This classification of elements started in the year 1817. Today we have a long form of periodic table, isn't it? Long form of periodic table. This is called long form of periodic table, modern periodic table. This table, okay, is from 1913. Right, and it was designed by Mosley. But I am speaking about what 1817, where the classification, the birth of classification started. 1817, and the first classification was done by Dobereiner. First classification was done by Dobereiner. And his classification is called as Dobereiner Triads. What do you mean by triads? Actually, elements in a group means going down, okay? Elements in a group, they have same physical and chemical properties. Therefore, he picked up these type of elements and placed three in a row, and he called them as triads. So I am writing few triads over here. And the first triad is Li-Na-K, Li-Na and K. Lithium, sodium and potassium. Second one is Cl-Bri. Chlorine, bromine and iodine. Next one is like SACT, sulfur, selenium and tellurium. And you find secondary group elements beryllium, magnesium, calcium, strontium and barium. Like this, these are called Dobereiner triads. Now, why did he pick up only these? Because they are having physical properties and chemical properties are similar. At the same time, there is one more logic in this. What was prevailing at that time was only atomic weight. There was no concept like atomic number. So what happened is the atomic weight of lithium is 7. The atomic weight of sodium is 23, and the atomic weight of potassium is 39. Now, what is the logic involved in this? The average atomic weight of first and the last average. So I am taking two quantities. Therefore, I am dividing it by 2. So 7 plus 39 is equal to 46 divided by 2 is equal to 23, and this 23 is the middle one. So what do you understand? The average atomic weight of first and last is equal to middle one. This was the logic behind Dobereiner triads, and this started in the year 1817. And when he was working with this, he had only 53 elements. And he could not make all the elements come into the triad. Therefore, his theory actually failed. Next comes another one in the year 1865. Okay, A.R. Newland. So the total number of elements at A.R. Newland were 56. Now what did he do? He classified them according to musical octaves. Sarigama Padanisa. Actually they are 7 in number, right? We generally don't stop at 7. We say Sarigama Padanisa, means we repeat the first one again as an 8th node. So let us see the same thing. So it is Sa, Ri, Ga, Ma, Pa, Da, Ni, and actually it's over. 7. They are just 7 musical octaves or 7 musical notes. But we don't stop. We say Sa. So what is happening if you give the numbering 1, 2, 3, 4, 5, 6, 7 and 8. So 8th one is like a sort of repetition. 8th is a sort of repetition because Sa and Sa is repeated. So he says that Dobereiner classification is based on music. See, A.R. Newland is explaining Dobereiner triads only. He is saying that Dobereiner triads are arranged according to musical octaves. How? Let us see. So it's lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, then comes sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, okay, like argon, potassium and calcium. Yes, clearly I did not take inert gases because they were not discovered by that time. Now what are the elements discovered only he took. So it is now 1, this is 2, this is 3 and this is 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and 16. So now let us consider this as Sa. So lithium over here, number 1 Sa, Re, Ga, Ma, Pa, Da, Ni, Sa. So 8th one again sodium with number 8. Re, Ga, Ma, Pa, Da, Ni, Sa. So again potassium with number 15. So come on, let us do 1 plus 15 because he told you to do average of first and last, and that will be equal to the middle one. We will see now. 1 plus 15 by 2. So it is 16 by 2. Answer is 8 and it is true. This is how A.R. Newland has proposed that Dobereiner Triads means each box containing 3 electrons, okay, so 3 elements, and that is similar to musical octaves. Then after A.R. Newland, there were so many other scientists who came forward to propose their model. Among them it is Pettenkofer, Dicha-Porteous, and in the year 1869, Mendeleev periodic table has come. Mendeleev periodic table and Noether Mayer's periodic table. Okay. Now we will see Mendeleev periodic table in the next video.